Hey guys, Buildzoid here, and today we're going to be taking a look at the answer to the question of can a $250 motherboard run a 7200 CL34 memory kit? Yeah, because that's actually what I was wondering. So Gigabyte sent along a Z790 Aorus Elite AX, as they do, and they also sent along a 2x16 7200 CL34 engineering sample single rank memory kit based on Hynix 16 gigabit A-die memory chips. And so this memory kit is rated pretty high in terms of speed, right? 7200 megabits per second. And admittedly, Gigabyte claims that this motherboard should support up to 7600 megabits per second, but it's a 6-layer PCB, it's a daisy chain. I had my doubts, okay? Like, if you told me a Z7, like, if you told me a Z690 motherboard would be, like, this good, like, because on the Z690, like, there was a really big gap between your, like, 6-layer daisy chain boards and your 8-layer daisy chain boards, at least for some manufacturers. And so, yeah, the idea that, like, this budget Z790 motherboard would be able to run this 7200 CL34 memory kit to me was kind of like, yeah, I wonder about that, especially because I've not been able to get this memory kit to go any higher than 7200, even on the Z790 Aorus Master, which is significantly more expensive and uses an 8-layer PCB with a daisy chain topology. Though it could also be just like early BIOS things and maybe my CPUs suck. Also, at high speeds, the memory gets like ridiculously sensitive to silly things like mounting pressure on the CPU socket. So, yeah, it might not be the board, it might be the CPU, it might be the, like, yeah, like, unfortunately, the faster RAM gets, the more previously insignificant variables become a big problem, right? With like, in DDR3 days, memory training took like seconds. You didn't even really notice that it was doing memory training, and everything was great. And now with like DDR5, everything is just mega complicated. So anyway, yeah, so 7200 CL34 Hynix 8i based memory kit. I'm using the i5-13600K. I don't know if the 13600K's memory controller is better than the 13900K. I haven't really tested that yet. And I'm just using an Asetek 240mm AIO for cooling the 13600K. Anyway, so those are the system specs. And the answer to the question of can it run a 7200 CL34 memory kit is yes, it can. So it passes 500% HCI mem test, so the memory is nice and stable. It passes 4 loops of ANTA 77 Extreme 1 in test mem 5. So, that's good. That took 2 hours and 30 minutes. And more importantly, or more like the most difficult part of this setup was passing 3,000, like almost, well, over 3,000 seconds of Y-Cruncher VST. And the reason that I went and tested specifically Y-Cruncher VST is because during testing, like when I was first setting this up, I was really struggling to get, far into test mem 5. Like I could usually make it to like pass 1 or 2, but I never really made it all the way to 4 passes. And so, while failing test mem 5 repeatedly over and over and over again, at one point I just kind of decided to see, like, hey, is there, like, what if I ran Y-Cruncher? What would that spit out in terms of errors? Because test mem 5, like, the main difference between, like, HCI mem test and test mem 5, in my experience, is that test mem 5 really hits the memory controller more. And so, if you really want to hammer the memory controller, you've got Y-Cruncher and LinPack as options, though Y-Cruncher is actually even harder on the memory controller than LinPack is. And so, while struggling to get testmem 5 to pass, I decided to try run Y-Cruncher. And the VST test failed immediately. Like, right off the bat. It took no time at all. VST errored out, like, it didn't make one pass. It just errored out immediately. And so I was like, okay, so maybe instead of worrying about getting testmem 5 to run, I should get VST to run, because VST is very upset about something. And as far as I can tell, it's probably the memory controller, because I tried dropping the ring clock like super low. At one point in time, I had the ring clock all the way down at 4.4 gigahertz. VST was still crashing. So that wasn't the issue. And it turns out that I needed to pump up a bunch of voltages that they're still perfectly safe. It's just like, it was interesting that there was like a bunch of voltages that I needed to raise to get this to work. And we will take a look at that. And I did tighten up the timings on the memory kit. It's not, it's not just bone stock 7200 CL34. Yes, the primaries are completely stock because, well, the primary timings, A, don't tighten that much. B, those tend to be like an easy place to get like hard to catch errors in my experience. Like a lot of your sub timings have pretty hard like breaking points for stable versus unstable. Primaries, not so much. So yeah, leaving the primaries at what the memory kit is rated for was just kind of like, I don't want to deal with that. Also, they really don't change performance that much because you're not going to be doing like you're not going to be doing 7200 with a TRCD much lower than 40. Actually, you're probably not even going to hit TRCD 40 at 7200 megabits per second with Hynix ADI, period. So, yeah, there's probably like 1 or 2 ticks of TRCD available for tightening. Cast latency might go down to CL28 if you shove a ton of voltage into the sticks, but with DDR5, raising the voltage can actually cause all kinds of other stability issues because, yeah, high memory speeds have very annoying interactions with extra voltage. So, yeah, that's fun. So the timings are tightened up. I do have round trip latency training turned on. Yeah, like TXP's at 4. And actually, we'll take a closer look at the timings in the BIOS, because basically all of the subtimings are, well, the TRFC is not super tight, but all of the timings are basically relatively tight. It's just that I left the primaries alone. So if you actually are tuning Hynix ADI, then your subtimings could potentially end up looking something similar to this, if you're, trying to get more performance out of it. Anyway, the 13600K is at 5.6 gigahertz with a -1 AVX offset, so that fixes the whole like getting stuck at 5 gigahertz thing, which is really frustrating because it's just a thing. Like, it's a thing since Intel 11th gen. Basically, you can't have a 0 AVX offset. Just for whatever reason, that's broken. At least on a lot of motherboards, that is broken. If you set the AVX offset to 0, the CPU gets stuck at its max all-core boost clock. Actually, no, I think it gets stuck at its like max boost frequency. So that's really dumb. Thanks Intel for, that being a thing. But the workaround for that is having a -1 AVX offset, which I think is a stupid workaround because I don't like CPUs that randomly downclock, but anyway, so the CPU, like, I don't consider this a 5.6 gigahertz overclock. This is a 5.5 gigahertz overclock, which is still significantly faster than a stock 13600K because the stock 13600K's max all-core frequency is really, really low. Anyway, so yeah, and for the ring clock, we're right now at 4.7 gigahertz. It might go higher, because I really think it was just a memory controller stability issue. Because again, I had the ring clock all the way down at 4.4 gigahertz and VST was still crashing. So I don't think it's a ring problem. I think it was like a system agent / memory controller issue, especially based on the voltages that I was raising. But anyway, so there might be more headroom in the ring, but it's not like a ton of headroom. I've run IDA. I ran IDA after running all of the stress tests, so this is not like a clean IDA run. 53.2 nanoseconds of latency, which it could be, like, I wish it was lower, but some of that's just the fact that I have all of the, like, I'm running it after all of the tests. Some of it's also just the primaries are still basically auto, so that's not helping. We have a ton of read, write, and copy bandwidth because we're at 7200 megabits per second, though it is worth noting that 8-core CPUs get higher read, write, and copy results than 6-core CPUs because the data has to go somewhere. So if you have more cores, you get more read speed. It also might be IDA hitting the L3 cache somewhat. That's another fun issue with IDA, is that it has a tendency to include L3 cache in your memory bandwidth measurements because it's a terrible benchmark. Yeah, anyway, so that's fun. And there you can see also Z790 Aorus Elite AX with the F3F BIOS. So anyway, now let's take a look at what actually went into getting this nightmare stable. And also, I guess it's worth noting that it is a potentially real, like, it is a potential risk when buying, like, high-speed XMP DDR5 kits, that you could buy, like, a 7200 CL34 kit or there's like 7600 rated kits available as well. You could buy one of those kits, put them in your motherboard, enable XMP, and it's just not going to be stable. Like, at all. Especially the 7600 rated memory kits. I would really not be surprised if a lot of people found out that, like, you turn on the XMP and just the whole thing just starts falling apart because, yeah, like, the amount of work that went into getting 7200 stable was quite the adventure. Anyway, so yeah, also here's HCI. I mean, not HCI, hardware info, and you can see that hardware info hasn't caught any errors. Yeah, the CPU did get quite hot when I tried to run LinPack on it. Unfortunately, I didn't do a full LinPack pass because there's a, like, software conflict between some of the memory stress tests, and I think it's TestMem5 and LinPack really don't like each other, so depending on what order you run them in, they don't work. Anyway, I tried to run LinPack, it was running at, like, half speed, and alternatively, I would have run, like, YCruncher's full test suite for, like, the CPU stability part of this. However, I can't open another. Oh, wait, I can. God damn it. Too late. Wait, so why couldn't I do that earlier? Oh, well, so yeah, I could have run YCruncher. So, well, too late. Anyway, the priority here is the memory overclock, the CPU side of it. Like, I can fix that later. Actually, I'm running so much core voltage that I really don't think the CPU is unstable as is. So anyway, let's take a look at what went into getting 7200 to actually freaking pass all of these tests. Because, yeah, it took forever. Because the thing is, you have to understand, I was crashing TestMem5 at like an hour and 30 minutes into it. Which is not fun. And I was doing that, like, forever until I sort of tried to run YCruncher and realized, wait a minute, there's a much bigger problem here than, like, one error within an hour and 30 minutes of TestMem5. I mean, sometimes it would also crash within 20 minutes and 30 minutes, but, you know, so, like, there'd be these erratic errors that would be showing up. Also, I have memory training, like, force enabled right now, so the post time's going to be great. It would be really stupid if it failed to train right now. It might actually be failing to train right now. I hate DDR5. I really do. RAM was never supposed to go over 4 gigabits per second. Like, it's a mistake. The board doesn't have a postcode, so there's not really anything for you to see. It's just it's just the DRAM, like the little indicator LED going back and forth. I didn't set up the camera. I didn't think I'd have this issue. You know, the worst part about Intel's DDR5 memory controller, especially at high speeds, is that sometimes it'll boot up and just be completely unstable for no apparent reason. So I do still need to check that, like, that isn't potentially an issue with this setup right now. Okay, now it booted, so it, like, doesn't like warm resets. Yeah, it doesn't like warm resets. That's fun. Anyway, so yeah, I have fast boot disabled, which is what forces memory training every boot. Which is, like, you want that when you're first dialing in the memory overclock, but ideally afterwards you would set it back to auto so that it doesn't do that every single time. And only does it when the motherboard, like, notices that it needs to do it, but... yeah. Anyway, here's the settings. You might notice that there's an awful lot of timings set to auto, and that is because a lot of these timings are not, you know, actual like, a lot of these timings don't correlate to registers on the CPU. So, like, for example, TRC is just not a thing on Intel CPUs, like, at all. It just doesn't exist, okay? There is no TRC register. Intel CPUs control this value just from the TRAS and TRP timings. So you don't have to, like, that's why you leave this on auto. Then TWR is a similar story. There is no TWR register on Intel CPUs. Instead, Intel CPUs use TWR pre, which is this timing down here. Yeah, so that's TWR pre. That's what controls your TWR timing. This is just how Intel CPUs work. For some reason, motherboard vendors like to include timings that don't exist in their BIOS for reasons I will never understand. I guess it makes the BIOS look more impressive if you have more settings in it. But yeah, there's just, like, basically anything that's left on auto either doesn't affect performance or literally doesn't exist. Though TRFC does exist, it's just not used in the default refresh mode that 13th gen CPUs have on Gigabyte motherboards, which is why that's on auto as well. If this was DDR4, then, you know, I would actually be using the TRFC timing, but with DDR5, it's just TRFC2 and TRFC per bank. You'll notice that these are higher than what you would use with Hynix MDI, and that's just the difference between ADI and MDI is ADI has slightly worse, takes slightly longer to refresh. It also doesn't do as tight read to precharge, doesn't go as low as on Hynix MDI. On MDI, you can set it ridiculously low. Like, it looks broken, basically. Because you can set it to values where it's like, this shouldn't be possible. And no, it's fine. And actually, right now, I think I have it a bit looser than it has to be. I think 12 would probably work, but yeah, I've not spent a ton of time tuning ADI yet, because so far my main priority with Hynix ADI has been getting 7200 megabits per second to work at all. Much less, you know, trying to dial in all of the timings at this speed. So this is sort of a starting point. But anyway, for the tertiaries, we've got 14.7 for the back-to-back reads. The 7 is as low as that goes. This probably could do 13 instead of 14, but don't really, like, you know, this was hard enough without absolutely minimizing every timing possible. Same goes for the, like, read to writes. These could probably go a little, like, one tick lower probably. Write to write might do 11 instead of 12. Write to write different group is at 7, so that's as low as it goes. It doesn't do 6. This might be slightly looser than it needs to be. This also might be slightly looser than it needs to be. But no, like, major problems with the timings here. Like, this is way faster than an XMP profile. But anyway, so that's the timings, which aren't really the priority here. Now let's take a look at the voltages, which are a priority. That's where basically all of the effort went into. So first of all, CPU V-core is up at 1.43 volts. That might not be necessary, though it is worth noting it's not actually that high because I'm on the low load line calibration setting, so there's plenty of V-droop. So under full load, the CPU is like below 1.3 volts. So it's not actually that much voltage. It's a lot of voltage at, like, idle, but the thing is, having a low load line calibration gives you better voltage regulation, and I've not yet checked the voltage regulation capabilities of this motherboard with the oscilloscope, so I don't know if like medium LLC would have acceptable voltage regulation performance. It might. It probably does. The Z790 Aorus Master has like incredible voltage regulation, so and the funny thing with Gigabyte Intel motherboards, at least, is that they tend to perform very similarly across their like entire lineup. That happened with Z690 at least, is like they all had basically the same voltage regulation performance, which was kind of fun. So if the Z790 is the same kind of situation, then yeah, even medium or high LLC on this board would be viable. And shouldn't like have any negative impact on the voltage regulation, but I haven't measured it yet, so I'm just going with low because I don't think I've seen any, like low LLC pretty universally works well on Gigabyte boards. You just need a lot of idle voltage. Anyway, this might be excessively high because I raised that while trying to, like, at one point I thought maybe I have ring instability and the ring is powered by the core voltage. So potentially, if you're getting like ring-related stability issues, more vCore can fix them. Except in this case, it didn't fix them because there wasn't a ring issue. So VCCSA is at 1.35 volts. This is almost certainly necessary because, yeah, I wasn't able to pass VST until I raised the VCCSA to 1.35 volts. I have VCC in at 2 volts because there's no reason not to set it to 2 volts, and it can help with stability when you're running higher system agent voltage or higher VDDQ CPU voltage, because VDDQ CPU and VCCSA are both generated from the integrated voltage regulator, which is fed by the VCC in voltage. So that's what's going on with those. Now, where the sort of, I guess, magic happens is these voltages right here, the PLL voltages. My best not stable pass of VST happened when I had 1.3 volts of VCCSA, and these like this. Like basically, at one point I was like, I just was at a total loss as to why the hell it just won't run. So I went and just gave all the PLL voltages 90 millivolts just across the board. Everybody gets 90 millivolts extra. Which is perfectly safe for the CPU. It's not going to harm it. And that got me to, I think, like 30 minutes of VST. So pretty good. And then I bumped up the VCCSA from 1.3 volts to 1.35, and I also raised all of the core PLL, ring PLL, and system agent PLL to 120. And that's how I finally got VST to pass. That's the configuration we just saw. Right, that's what had all of the stress tests finishing. So yeah, it looks like if you're going to be pushing high-speed memory kits, the PLL voltages might be extremely helpful. I would generally not go above like 150 on them, but I'm not entirely certain that even, yeah, like they only go up to 225. But yeah, like plus 120 really shouldn't harm the CPU in any way, shape, or form. They do sweet spot, at least in my past experiences with other CPUs. Like each CPU will potentially have like specific values that it prefers. There might also be CPUs that just kind of don't care, where it's like more is better. Yeah, here I kind of like these aren't minimized, right? Like I'm not entirely certain that we need all that extra core PLL voltage. We probably don't, but I ran out of patience. Like, I spent multiple days trying to get 7200 to freaking pass VST. So, at the point where I started raising the PLL voltages, I was just like, look, I was actually really tempted to raise even the MC PLL voltage up to 120. Yeah, I don't know why I didn't. I guess it was just kind of like, I'll just raise the first 3. If that doesn't help, I'll raise memory controller PLL voltage as well. But yeah, luckily for me, by the time I did, like these settings, were stable. It passed VST and ran it for almost an hour. Yeah, so that's kind of that. Is just like PLL voltages are potentially, if you're pushing high memory speeds, like the PLL voltages can be extremely helpful for getting high memory speeds to work. And I kind of think it's probably the system agent voltage that did most of the heavy lifting, along with like the ring PLL voltage. I don't think it was the core PLL voltage. Because again, like I had the ring clock all the way down at 4.4 gigahertz and it still wasn't doing VST. Like, to me, that's a pretty clear indication that the issue isn't the ring itself, but either the connection to the ring or the, like, because the memory controller connects to, as far as I know, the memory controller goes through the system agent to the ring. So the system agent actually acts as a sort of interconnect of everything. So yeah, I think probably most of the benefit is from the system agent voltage itself, maybe from the ring PLL voltage. But yeah, I've not done that much testing on this. I don't plan to do that much testing on this. This takes way too much time and effort. I do hope that these settings will be the basis of maybe like a 7400 megabits per second overclock on this motherboard. Maybe even 7600, but I have my doubts about 7600, like serious doubts about 7600. But yeah, so that's the thing that was necessary to get 7200 stable on this motherboard. That's the whole reason I'm making this video, is like, look, if you're going to be buying, or if you're going to be pushing DDR5 kits to, you know, over 7,000 megabits per second, well, you should use Y-Cruncher VST for stability checking. And the nice thing is it doesn't even run that hot, though I would also say you should generally be able to pass the full Y-Cruncher stress test, so yeah, that. But where was I going with it? Yeah, so you should be able to just pass Y-Cruncher in general, but the VST test specifically, it seems to be great at just hammering the memory controller, which you really want to do if you're going to be pushing high memory speeds like this. Yeah, if you're doing that, you might need to raise your like ring PLL, system agent PLL, memory controller PLL. I'm kind of sad that I raised them all at the same time because I don't know which one does it. But the thing is, as long as you don't set them to anything unsafe for you know, the lifespan of the CPU, then it's like it doesn't really matter. So yeah. Anyway, so that was like the big thing for this to get this stable, was setting the PLL voltages to these levels, because before it wouldn't run VST. Admittedly, I raised them at the same time as the system agent voltage, so maybe it wasn't entirely necessary to raise them, but like maybe it was mainly this extra system agent voltage that was cleaning up the stability issues, but I did both at the same time. So I, you know, like if you're tuning your own system, do consider playing with the PLL voltages. Anyway, for the DRAM voltages, right, VDDQ CPU and VDD2 I have at 1.4 volts, and then the memory voltage itself I have at like 1.43. This is like the VDD voltage primarily helps with memory timings. The VDDQ voltage is sort of critical to the frequency. Now, the funny thing with the VDDQ voltage is you can have issues with setting it too high. Which is why I have it at 1.4 volts. So yeah, it's like there is, like, this is why I hate DDR5. I mean, to be fair, already on DDR4, when pushing very high memory speeds, you would run into situations where more voltage would actually lower stability, even on memory chips that really like a lot of memory voltage, like Samsung B-Die, for example. But with DDR5, it's much more of a real problem, because with DDR4 it was like you'd only really run into that when you were like going hard for max memory speed, whereas with DDR5 like you're constantly at memory speeds so high that the sort of issues that potentially crop up with higher voltages now show up just kind of potentially constantly. So yeah, and the memory kit, like the XMP on this memory kit is actually set at 1.4 volts. So yeah, that's kind of why I stuck to it, because it's like, well, at least Gigabyte validated at some point in time that this memory kit runs properly at 1.4 volts. So I'm not gonna, you know, test if like I'm not gonna fight the voltage related stability issues if I can avoid them, considering how many other issues I'm already having with 7200 as is. Anyway, and then for VPP voltage, I raised that up to 1.9 volts. This probably isn't necessary. It can sometimes help on some memory kits. It's also perfectly safe. It's not going to hurt the memory sticks or whatever. But yeah, probably like, so on one hand, like I've never seen it cause issues. Sometimes it helps. Most of the time it does nothing. So it's one of those voltages that like slightly bumping it is like, it's not like, yeah, it'll slightly increase your RAM's power consumption, I guess. Like it's the only real downside to raising it if you don't absolutely need to raise it. So, um, yeah, but I was really running out of just ideas to try get this to work, right? Like, um, so the VPP voltage got bumped relatively early into the process compared to how late into the process I tried raising the PLLs. Um, so yeah, there. Oh, and I guess I should also mention that, of course, I have the E-cores disabled because the E-cores make everything more difficult. Not in terms of, like, memory stability, they just cause a lot of fun software compatibility issues, so that's why I hate them so much. You know, like, the main problem with Ryzen's chiplet design is that, potentially some applications might have a hard time dealing with the fact that not all of the cores have access to the same pool of L3 cache. The E-cores are like that, but way worse. Like the E-cores cause a whole new range of just software issues that just like Intel insulted AMD for gluing their CPUs together, but they're over here coming up with just ugh. Like when you need a special OS for the CPU, that's when it's like, oh, this is kind of a problem. Now, to be fair, Ryzen doesn't work properly on Windows 7, but yeah. Anyway, I would prefer it if CPU manufacturers would stop coming up with innovations that require special operating systems. Um, anyway, yeah. So the E-cores are turned off for this. I'm not going to be turning them back on. I don't like them. Um, and I don't miss them either. Like I don't do like my job isn't to run Cinebench, so yeah. Like, that's my view of the E-cores. Anyway, so the main takeaway for this video is if you're struggling with stability on high-speed memory kits, especially if you're crashing in like Y-Cruncher VST, PLL voltages. Definitely consider raising the PLL voltages. The main ones are just CPU ring, because GT is that's like the iGPU PLL voltage, which I don't know why you'd ever have to raise that, because why are you using the iGPU? And then we have the Atom PLL voltage, which is for the E-cores, which I turned off. So I don't need to worry about them. So, yeah. And then there's the memory controller PLL voltage. So that's kind of that. Yeah, hopefully this is somewhat helpful if you have a high-speed DDR5 kit and you're struggling with stabilizing it. Because I did. I really struggled. This took forever to get stable. So, yeah. That's it for the video, and now I will proceed to torture myself by trying to get 7400 to work. So, thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comments section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's like text versions of my videos on there. And yeah, so there's Patreon. There's also the AHOC Teespring store where you can pick up shirts, hoodies, posters, the usual YouTuber merch. And I've also got a Bandcamp, where I post like industrial noise stuff. So if you want to check that out, it would be appreciated. Links to all of that down in the description. That's it for the video. Thank you for watching, and goodbye.